Hello everyone, welcome to today's lecture. In today's lecture, we will see the theory portions of the chapter statistics. So in today's class, we will start measures of central tendency. After that, we will see what is mean or arithmetic mean, what is geometric mean or GM, harmonic mean or HM, what is median, what is mode, what is range, what is mean deviation, which is called MD, what is standard deviation, in short form it is called SD, what is variance, right? So these things we will see. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So let us start with the section measures of central tendency. A value which describes the characteristics of entire data is called an average or a central value. Generally, an average lies in the central part of the data, and therefore such values are called the measure of the central tendency, right? Clear? So average is basically, suppose we have a data, clear? So average will lie on the central part of that data, right? Clear? And it is described as the characteristics of entire data, clear? Okay. So what is mean or arithmetic mean? The sum of all the observations divided by the number of observations is called the mean, and it is denoted by x bar, right? The most stable measure of central tendency is mean, right? So mean is basically the most stable measure of the central tendency. You have to keep in mind. Suppose we have a data set. If x1, x2, x3 till xn with the n observations, then mean is given by x bar is equal to x1 plus x2 plus x3 till xn upon n, and it is equal to summation of xi upon n, right? Or x bar is equal to a plus summation of I is equal to 1 to n di upon n, where di is basically xi minus a, which where a is assumed mean, right? A is called assumed mean. If corresponding frequencies of n observations are f1, f2, f3 till fn, then x bar is f1 x1 plus f2 x2 till fn xn upon f1 plus f2 plus f3 till fn, right? And it is equal to summation of I is equal to 1 to n fi xi upon summation of I is equal to 1 to n fi, or x bar is equal to a plus summation of I is equal to 1 to n fi di upon n, where di is equal to xi minus a, and capital N is basically summation of I is equal to 1 to n fi, right? If corresponding weights are w1, w2, w3 till wn, then the weighted mean x bar w is basically summation of wi xi upon summation of wi, right? It is called weighted mean. Got it? Now, next, what is mean? Arithmetic mean. If x1 bar, x2 bar till xk bar be the mean of k sets of observations of size n1, n2, n3 till nk respectively, then their combined mean x bar 1k is equal to n1 x bar x1 bar plus n2 x2 bar plus n3 x3 bar till nk xk bar upon n1 plus n2 plus n3 till nk, right? Here x1 bar is equal to mean of first set of observations, right? N1 is equal to number of observations in the first set. X2 bar is equal to mean of second set of observations. N2 is equal to number of observations in second set, and so on, right? Clear? So you can note that the sum of the deviations of the individual values from arithmetic mean is always 0, right? That is summation of xi minus x bar is equal to 0. Clear? You have to keep in mind. Proof of this: summation of I is equal to 1 to n xi minus x bar is equal to xi minus x bar plus x1 minus x bar plus x2 minus x bar till xn minus x bar. So it is equal to x1 plus x2 plus x3 till xn minus nx bar. Clear? Now x1 plus x2 plus x3 till xn can be written as nx bar minus nx bar is equal to 0. Clear? Because x1 plus x2 plus x3 till xn upon n is equal to x bar, right? Now the sum of squares of deviations from of the individual values is least when taken from arithmetic mean, that is summation of xi minus x bar whole square is least, right? You have to. Next, what is geometric mean? GM. If x1, x2, x3 till xn are n observations, then nth root of the product of all observation is called geometric mean, right? If x1, x2, x3 till xn are n non-zero positive observations, then geometric mean is x1, x2, x3 till xn to the power 1 by n, right? If corresponding frequencies of each of the observations are f1, f2, f3 till fn, then geometric mean is x1 to the power f1, x2 to the power f2 till xn to the power fn whole to the power 1 by n, right? Where n is equal to summation of I is equal to 1 to n fi, right? You have to keep in mind. Next, harmonic mean HM. The harmonic mean of any set of non-zero observations is the reciprocal of the arithmetic mean of the reciprocals of the observation, right? The harmonic mean of n items x1, x2, x3 till xn is defined as hm is equal to n upon 1 upon x1 plus 1 upon x2 till 1 upon xn, right? Which is equal to 1 upon 1 by n summation of I is equal to 1 to n 1 upon xi, right? Which is equal to 1 upon n summation of I is equal to 1 to summation of I is equal to 1 to n 1 by xi to the power minus 1, right? It is called harmonic mean. If the corresponding frequencies of each observations are f1, f2, f3 till fn, then harmonic mean can be calculated as 1 by n summation of I is equal to 1 to n fi upon xi whole to the power minus 1, right? Relation between arithmetic mean, geometric mean and harmonic mean is geometric mean whole square is equal to arithmetic mean into harmonic mean, right? You have to keep in mind. Next, median. What is median? If the observations are arranged in ascending or descending order, then the value of middle observations is defined as the median, right? Value of middle observation is defined as the median, right? Let x1, x2, xn be n positive be n observations arranged in ascending or descending order. Then if n is odd, then median is equal to n plus 1 by 2 observation. If n is even, then median is equal to n by 2 plus n by 2 plus 1th observation upon 2, right? If in a continuous distribution, the total frequency is capital N, then the class whose cumulative frequency is either equal to capital N by 2 or just greater than capital N by 2 is called the median class. And in that case, median is equal to L plus capital N by 2 minus C upon F into H, where L is the lower limit of the median class, F is equal to frequency of the median class, as H is equal to size of the median class, C is equal to cumulative frequency of the class preceding the median class, right? Clear? You have to keep in mind. Next, mode. Mode is the observation which has maximum frequency, right? So mode is that observation which has maximum frequency. If x1, x2, x3 till xn are the n observations and corresponding frequencies are f1, f2, f3 till fn, then the observation of maximum frequency is a model value, right? In a continuous distribution, the interval which has maximum frequency is called model class. In that and in that case, mod is equal to L plus f1 minus f naught upon 2 f1 minus f naught minus f2 into h, where L is equal to lower limit of the model class, f1 is equal to frequency of the model class, f naught is equal to frequency of class preceding the model class, f2 is equal to frequency of class succeeding the model class, h is equal to class size. Now relation between mean, median and mode. Mod is equal to 3 median minus 2 mean, right? Mod is equal to 3 median minus 2 mean. You have to remember this. It is not necessary that a distribution has a unique mod, right? A distribution should have unique mod is not necessary, right? Next, measure of dispersion. Measure of dispersion. A measure of dispersion is designed to that state the extent to which the individual observations vary from their average, right? The commonly used measures of dispersion are basically first range, second mean deviation, which is called MD, and third standard deviation, which is called ST, right? And fourth is variance. Clear? So these are basically four types of measure of dispersions, right? Next, range. The difference between maximum and minimum observations is called range, where range is equal to L minus L, S where L is equal to maximum observation and S equal to minimum observation, right? Coefficient of range is equal to L minus S upon L plus S, right? Coefficient of range is equal to L minus S upon L plus S. Now let us see what is mean deviation, which is called MD. The mean of the absolute deviations of the value of the variable from a measure of their average is called the mean deviation, which is called MD. If x1, x2, x3 till xn are n observations, then mean deviation MD is equal to summation of I is equal to n mod xi minus z upon n, where z is equal to mean or mod or median, right? Next, if corresponding frequencies of each observations are f1, f2, f3 till fn, then mean deviation MD is equal to summation of I is equal to 1 to n fi into fi mod xi minus z upon n, where n is equal to summation of I is equal to 1 to n fi, right? And coefficient of mean deviation will be mean deviation upon corresponding average, right? Mean deviation upon corresponding average. Next, mean deviation is least when deviations are taken from median, right? So mean deviation will be least when the deviation will be taken from the median. Got it? Next, standard deviation. So the square root of arithmetic mean of the squares of the deviations of the observations from the arithmetic mean is called the standard deviation, and it is denoted by sigma, right? If x1, x2, x3 till xn are n observations, then sigma is equal to root over summation of I is equal to 1 to n xi minus x bar whole square upon n, which can be also written as equal to root over 1 by n summation of I is equal to 1 to n xi square minus 1 by n summation of I is equal to 1 to n xi whole square. You can see the proof of this. See, sigma square can be written as summation of I is equal to 1 to n xi minus x bar whole square upon n, right? So we can observe that summation of I is equal to 1 to n xi minus x bar whole square is equal to summation of I is equal to 1 to n xi square minus 2 xi x bar plus x bar x bar square, and it is equal to summation of I is equal to 1 to n xi square minus 2 x bar summation of I is equal to 1 to n xi plus n x bar whole square plus n x bar square, right? Let us assume it as equation 1. We know that x bar is equal to 1 by n summation of I is equal to 1 to n xi, right? So nx bar square is equal to summation of xi into 1 by n summation of xi, right? So 2x bar summation of xi is equal to 2 times. X bar can be written as 1 by n summation of xi, and summation of xi can be written as summation of xi, right? So 2x bar summation of xi is equal to 2 times 1 by n summation of xi into summation of xi, right? Into summation of xi. Clear? So summation of xi minus x bar square is equal to summation of I is equal to 1 to n xi square minus 2 1 by n summation of xi into summation of xi plus n times 1 by n summation of xi whole square, right? Got it? Which is equal to summation of I is equal to 1 to n xi square minus 1 by n summation of I summation of xi whole square, right? Therefore sigma square can be written as 1 by n summation of xi square minus 1 by n summation of xi whole square, right? So if corresponding frequencies of each observations are f1, f2, f3 till fn, then sigma is equal to root over summation of I is equal to 1 to n fi into xi minus x bar whole square upon n, which can also be written as equal to root over 1 by n summation of I is equal to 1 to n fi xi whole square fi xi square minus 1 by n summation of I is equal to 1 to n fi xi whole square. Clear? Where n is equal to summation of I is equal to 1 to n fi. Uh, you can see the proof of this. Sigma is equal to root over summation of fi into xi minus x bar square upon n. Therefore, sigma is equal to summation of fi into xi minus x bar whole square upon n. So we can observe that summation of fi into xi minus x bar whole square is equal to summation of fi into xi square minus 2xi into x bar plus x bar whole square is equal to summation of fi into xi square minus 2x bar summation of fi into xi plus summation of fi into x bar square, right? Got it? Now, in the standard deviation section, summation of x bar square is equal to summation of x bar square, since x bar square into summation of fi is equal to n times x bar square, right? And 2x bar summation of fi xi is equal to 2n summation of x bar square. Therefore, summation of fi into xi minus x bar whole square is equal to summation of I is equal to 1 to n fi xi square minus 2n x bar square plus n x bar square, right? Summation of fi into xi minus x bar whole square is equal to summation of fi xi square minus n times x bar square, right? Sigma square is equal to 1 by n summation of fi xi square minus n x bar square, right? Whereas sigma square is equal to 1 by n summation of fi xi square minus x bar square, right? Since x bar square is equal to 1 by n summation of fi xi whole square, right? Therefore, we can write sigma square is equal to sigma square is equal to 1 by n summation of fi xi minus 1 by n summation of fi xi whole square, right? Clear? Now, let us see what is variance. So the square of a standard deviation is called variance, and it is denoted by sigma square, right? It is denoted by sigma square. Coefficient of variance is basically x sigma upon x bar into 100. Clear? In two different series having n1 and n2 observations and whose corresponding means and variances are x1 bar and x1 bar x2 bar and sigma 1 square sigma 2 square, then their combined variance can be calculated as sigma square is equal to n1 sigma 1 square plus n2 sigma 2 square plus n2 plus n1 sigma n1 d1 square plus n2 d2 square upon n1 plus n2, right? Where d1 is equal to x1 bar minus x12 bar and d2 is equal to x2 bar minus x12 bar. Clear? And x12 bar is equal to n1 x1 bar plus n2 x2 bar upon n1 plus n2, right? You have to keep in mind, right? If x bar, me, m naught and sigma represents mean, median, mode and standard deviation respectively of x1, x2, x3 till xn, then mean of ax1 plus b, ax2 plus b, axn plus b is ax bar plus b, right? You can see the proof. Mean will be equal to ax1 plus b plus ax2 plus b till axn plus b upon n. So we can write it separately as, let us take a as common, then you can write a times x1 plus x2 plus x3 till xn upon n plus nb upon n, right? Which is equal to ax bar plus b. Now median of ax1 plus b, ax2 plus b till axn plus b is equal to is ame plus b, right? Ame plus b. Let us see the proof of this. Original data set x1, x2, x3 till xn with median me when n is odd. So me is equal to x n plus 1 by 2, x n plus 1 by 2, right? So median for new data set is n plus 1 by 2 term of new data set. Now new median will be a x n plus 1 by 2 plus b, right, which is equal to a m e plus b, right. Now for n even, when n is even, me is equal to x n by 2 plus x n plus n by 2 plus 1 upon 2. So median from for new data set is mean of n by 2th term and n by 2 plus 1th term, right. New median is equal to a x n by 2 plus b plus a x n by 2 plus 1 plus b upon 2. So a into x n by 2 plus x n by 2 plus 1 upon 2 plus b, which is equal to a me plus b, right, a me plus b. Now mode of ax1 plus b, ax2 plus b till axn plus b is amo plus b. Assume mob mod of x1, x2, x3 till xn, right? Clear? Therefore, m naught appears more than any other varies in data set ax1, ax2 till axn, right? Clear? Next, standard deviation of ax1 plus b, ax2 plus b till axn plus b is mod a into sigma. Let us see the proof. Standard deviation for x1, x2, x3 till xn is sigma is equal to root over 1 by n summation of xi minus x bar whole square. New deviation of for ax1 plus b, ax2 plus b till axn plus b is sigma n is equal to root over 1 by n summation of axi plus b minus ax bar plus b whole square, right? Which is equal to 1 by n summation of axi minus ax bar whole square, because uh, b and minus b will cancel out. So it will be equal to root over a square by n. Let us take a as common. Therefore, it is a square by n summation of xi minus x bar whole square. So when you will take a square outside the root, it will be mod a root over 1 by n summation of xi minus x bar whole square, right? So sigma n is equal to mod a into sigma, right? Sigma n is equal to mod a into sigma. Got it? You have to keep in mind. So in this way, we have discussed the concept of statistics in today's lecture. Hope you understood the concepts, right? And hope you liked today's lecture. Some questions based on statistics. So in today's class, we will practice from question number 1 to question number 6. Let us start with question number 1. Question number 1 says the mean of a data set consisting of 20 observations is 40, and one observation 53 was wrongly recorded as 33, right? Then the correct mean will be. So the hint of this question is, we know that suppose we have n data set, then the mean of that data set will be x1 summation of xi from 1 n equal to from r equal to 1 to n, I is equal to 1 to n upon n, right? Since we have 20 observations, so summation will be, and mean is 40, right? So x1 plus x2 till x40 till x20 upon 20 is equal to 40, right? Clear? So we will find the summation of all the observations, clear, which is equal to 20 into 40. And since one observation 53 was wrongly recorded as 33, clear. So we will now correct that observation, and after that we will find new mean, right? Clear? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will The formula and key points we'll use in this question is mean. Mean is equal to sum of all the observations upon number of observations. You know that, right? So it is given that summation of summation of x incorrect upon 20 is equal to 40. Therefore, summation of x incorrect will be 20 into 40, which is equal to 800. Clear? Now, summation of x correct will be equal to, since 20. Therefore, summation of x correct upon 20 is equal to 820 upon 20. Clear? Therefore, correct mean is equal to 41. Clear? Correct mean is 41, which is option A. Right? Option A is right choice, 41. Got it? Let us move to the next question. Question number 2. Question number 2 says, if the variance of 1, 2, 3, 4, 5 till 10 is 99 by 12, then the standard deviation of 3, 6, 9, 12 till 30 is. We basically have to find the standard deviation, right? Clear? So we know that standard deviation is basically root over variance. Clear? And we will apply the condition that if a standard deviation is 3 times the variance, then what will be the like if all the data set is 3 times the current data set, then what will be the change in the standard deviation, right? From variance to standard deviation. Clear? So after applying the condition, you the solution part. See, the formula and key points we'll use in this question is standard deviation sigma can be calculated as sigma is equal to root over summation of xi minus x bar whole square upon root over n, right? Variance sigma square is equal to summation of xi minus x bar whole square upon n, right? If sigma represents the standard deviation of xi, x1, x2 till xn, then standard deviation of ax1 plus b, ax2 plus b till axn plus b is modulus of a into sigma, right? Now see, given sigma square is equal to, that is variance is equal to 99 by 12, right? See, that is sigma square is equal to 99 by 12, which is equal to 33 by 4. Therefore, sigma can be calculated as root 33 by 2, right? Sigma is equal to root 33 by 2. Clearly, standard deviation of the required series will be equal to 3 sigma. Clear? By using the formula that we have just discussed, right? So, standard deviation of the required series will be 3 sigma, which is equal to 3 root 33 upon 2. Clear? Therefore, option B, 3 into root 33 upon 2 will be the right answer. Got it? Okay, let us move to the next question. Question number 3. Question number 3 says the mean of n terms is x bar. If the first term is increased by 1, second by 2, and so on, then the new mean is. We basically have to find the new mean. Clear? So the hint of this question is mean of n terms is given x bar, right? Clear? So we will apply the formula of mean of n terms, which is summation of xi, which I is equal to 1 to n upon n is equal to x bar. And if first term is increased by 1, second term is 2, so nth term will be increased by n, right? So we will have to calculate the new mean. Clear? So now we have all the data sets, so we can easily find the mean, right? Okay, in terms of the x bar, right? We have to find mean in terms of x bar. So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution part, right? part. See, the formula and key points we'll use in this question is mean x bar is equal to summation of I equal to 1 to n xi upon n. So sum of the first n natural numbers is 1 plus 2 plus 3 till n is equal to n into n plus 1 by 2. So let us move to the solution. Let the observations be x1, x2 till xn. Then x bar is equal to x1 plus x2 till xn upon n. Now, when the first term is increased by 1, second term by 2, and so on, then the observations will be x1 plus 1, x2 plus 2 till xn plus n, right? Therefore, new mean is equal to x1 plus 1 plus x2 plus 2 till xn plus n by n. So it can be further separated as x1 plus x2 till xn upon n plus 1 plus 2 plus 3 till n upon n, right? Which is equal to x bar plus n into n plus 1 by 2 into n, which is equal to x bar plus n1 plus x bar plus n1 n plus 1 by 2, right? X bar plus n plus 1 by 2. Therefore, option C, which is x bar plus n plus 1 by 2, is the right choice, right? And question number 4. Question number 4 says the mean of the data set comprising of 16 observations is 16. If one of the observations valued 16 is deleted and three new observations valued 3, 4, and 5 are added to the data, then the mean of the resultant data is. We basically have to find the mean of the resultant data. So what we can do, the mean of the first 16 mean of the 16 observations is 16. So summation of xi n is equal to I is equal to 1 to 16 is basic upon 16 is equal to 16. So we can calculate the sum of all the data sets. Now the data solution. See, the formula and key points we'll use in this question is mean x bar is equal to summation of I is equal to 1 to n xi upon n, right? So given x1 plus x2 plus x3 till x16 upon 16 is equal to 16. Therefore, summation of I is equal to 1 to 16 xi is equal to 16 into 16. So sum of new observations is equal to summation of I is equal to 1 to 18 yi is equal to 16 into 16 minus 16 plus 3 plus 4 plus 5, which is equal to 252. Therefore, the number of observations has increased by 2, which is equal to 18. Therefore, the new mean is equal to summation of I is equal to 1 to 18 yi upon 18, which is equal to 252 upon 18, which is equal to 14. Clear? Then the sum of the mean of the resultant data will be 14. Therefore, option D, 14, is the right choice. Got it? Question number 5. Question number 5 says if the sum of deviation of a set of values x1 x2 till xn measure from 59 is 20 and from 54 is 74, then the sample size n and the sample mean is. So the hint of this question is sum of deviations is given. Sum of deviations is given. Uh, given. So from 59 sum of deviation is 20 and from 54 sum of deviation is 70. So we will try to apply the formula of how we will take deviations, right? And after that we can easily find the sample size n and the sample mean, right? So in this way we can you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution part, right? Solution part. The formula and key points we will use in this question is deviation is equal to summation of I is equal to 1 to n xi minus mean. Therefore, sample size equal to number of elements or observations in sample space. So sample mean is equal to sum of all the observations in sample upon total number of observations in sample. So let us see the solution. We have from 59 sum of deviation is 20. Therefore, summation of I is equal to 1 to n xi minus 59 is equal to 20. And from 54 sum of deviation is 70. So summation of I is equal to 1 to n xi minus 54 is equal to 70. So from equation 1 equation 1 we will get summation of I equal to 1 to n xi minus 59n is equal to 20. And let us assume it as equation 3, which is sum of I is equal to 1 to n xi will be equal to 20 plus 59 n. So let us assume it as equation 3. And similarly from equation 2 we will get summation of I is equal to 1 to n xi is equal to 70 plus 54n. So let us assume it as equation 4. Clear? So now we can equate equation 3rd and equation 4. Therefore we will get 70 plus 54n is equal to 20 plus 59n. Therefore 5n is equal to 50. So we will get n is equal to 10, right? N is equal to 10. So from equation 3 we will get summation of n I is equal to 1 to n xi is equal to 610. Therefore sample mean is equal to sum of all the observations in sample upon total number of observations in sample, right, which is equal to 610 upon 10. Therefore sample mean is equal to 61, right? Sample mean is equal to 61. Got it? Question number 6. Question number 6 is the average marks of boys in a class is 52 and that of girls is 42. The average marks of boys and girls combined is 50. The percentage of boys in the class is clear. So the hint of this question is we will take number of boys as x, number of girls is as y. Clear? And the average marks of boy in the class is 52. We will apply the average condition in boy and also in average conditions girl. And average marks of boys and girls combined is 50, right? So we will take average of class and equate it to 50. And after that we will have two equations in terms of x and y. So we can easily find x in terms of y or y in terms of x. And after that we can easily find the percentage of boy in the class, right? So in this way you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds we will discuss the solution. So solution part. See, the formula and key points we will use in this question is percentage of A out of B is basically A by B into 100%, right? See the solution. Let the number of boys and girls be x and y. Therefore 52x plus 42y is equal to 50 times x plus y, right? Now so 52x plus 42y is equal to 50x plus 50y. Therefore 2x is equal to 8y. So x is equal to 4y, right? So we got x in terms of y. Therefore total number of students in the class in terms of y is x plus y. So write x in terms of y, which is 4y plus y is equal to 5y. Therefore required percentage of boys will be 4y upon 5y into 100, which is equal to 80%, right? Which is equal to 80%. Right, which is equal to 80%. Therefore the combined therefore the percentage of boys in the class is 80%, right? Percentage of boy in the class will be 80%. Got it? Therefore option C, 80% is the right answer. Got it? Thank you so much.